Have you ever wondered why nothing can go faster than light? Scientists say the speed of light is fixed, but why? Is it a cosmic speed limit or something deeper? Today, we'll break it down in a simple, mind-blowing way. Stay tuned, you'll never see light the same way again. If I asked you what is infinity plus 1, I believe you will answer without hesitation. Equals infinity. However, this seemingly simple question, but with a 99%, it has nothing to do with really understood physical phenomena. The speed of light remains unchanged. The space we live in is three-dimensional. In 3 dimensions, everyone has their own frame of reference. In their respective reference frames, everyone is the center of the universe. For example, in this person's frame of reference, the car is in motion. He is static. But in the reference frame of the car is stationary. It was this guy on the side of the road. No matter in which frame of reference, it only takes 3 dimensions. You can locate the position of surrounding object. The 3 dimensions are left and right, up and down, before and after, but these reference frames move the 4th dimension of the universe, time, in order to draw the dimension of time. Imagine we come to a street. Down this street, A standing on the side of the road, B drives a car by. From a different perspective, A is static. B moved to the right again. Suppose we put the picture of the car moving is taken needle by needle, then stack the captured images together. At this point, it can represent the spacetime map left by time. In this spacetime diagram, A and B are both moving into the future. As time goes by, they leave a trail. And that trajectory line is their world line. A world line is a vertical line. So the world line of B is a straight, sloping line. The current picture is a spacetime diagram drawn under the reference frame of A. If we switch to the reference frame of B, what will happen to this picture? First, in the reference frame of B, B is static. Therefore, we need to pan all the images to the left. The position of B in space remains unchanged. At this moment, B's world line becomes a vertical line. Now this picture B is still. A is moving to the left. We just did this series of operations, officially completed a rate increase transformation. By panning each image, we can change the frame of reference. From a different perspective, B is in motion, but from the perspective of B is a movement. Motion is relative. If B throws a small ball forward, in the opinion of B, the speed of the small ball is the normal ball, thrown at a speed of 10. But for A, the speed of the ball is faster than the speed of the bullet. Here's why. The car is also moving to the right at a very high speed. Under the Galilean transformation, the speed of the ball is equal to the speed of the ball, speed when being planed out, plus the speed of the car. So far, so good. But one of the great discoveries of the 20th century smashed it all to pieces. And that was the discovery that the speed of light does not change. Now imagine this. And B turn on the flashlight at the same time. The speed of light emitted by each flashlight every second, 299,792,458 meters. From a different perspective, B flashlight. The speed of the light emitted should be slightly faster. However, to everyone's surprise, the speed of these 2 beams of light, it's still 299,792,458 meters per second. This is the constant speed of light. In order to understand this bizarre phenomenon, imagine that a beam of light on each side. In a frame of reference, both beams have the same speed. In the reference frame of B, as the image moves to the left, the world line of these 2 beams should be tilted. Oblique. So for B, say these 2 beams of light should be one going faster than light. The other is slower than the speed of light. But the truth is, the speed of light remains the same. In order to change the frame of reference, the speed of light remains the same. The only way is, while moving the image along the spatial direction, we need to move these images in time. This way of moving is the only way, allows us to change the frame of reference. It can maintain the speed of light. We just did this series of operations. A Lorentz transformation is officially completed. In the Lorentz transformation, with different viewing angles, space and time will change. The time interval between two events, the sequence of events, even the lengths of objects become relative. Take these two events as an example. In the current frame of reference, the time interval between them is 1 second. But if we change the frame of reference, the time interval between them has become 1.1 seconds. A car in its own frame of reference, it's for meters long, but in the frame of reference of roadside pedestrians, it has become 3.8 meters in length. So, why does the spacetime graph transform in this way? Now imagine we're in a city. If you look down on the city from above, we can get a map with city road information. If you rotate the map, the position and direction of the road seem to change. However, this is obviously an illusion. In the real world, no matter how we rotate the map, the road to north and south still points north and south. It's like rotating a map in time and space. Each wheel magnetic transformation, it's like rotating the map once. In the rotating map example, every spin doesn't change the course of the road. So again, in the Lorentz transformation, each time the reference frame is changed, a straight line is still a straight line. But unlike rotating maps, the Lorentz transform seems to distort the map of spacetime. This distortion will directly change the distance between two points, and the trajectory of the rotating map is a circle, and the trajectory of the Lorentz transformation, it's a hyperbola. So, how do you make these two rotations completely equivalent? In fact, the current spacetime map, it doesn't represent the actual four-dimensional spacetime map. It's just a projection of four-dimensional spacetime. It's like projecting the Earth onto a two-dimensional plane, distance on a 2D map. It doesn't represent real distance in 3 dimensions. Although the center point, the distance to the hyperbola looks different, but the true distance they represent, it's all the same. Normal rotation. One rotation is 360 degrees. Infinite spins. The number of degrees of rotation is infinity. Same. Hyperbolic rotation under Lorentz transform. It can rotate to infinity. The angle of rotation represents how fast the object is moving. We call the degree of speed at which an object moves. For example, the speed of the car is the reference frame of the car itself. Angle with passerby reference system. If the car starts to accelerate, it increases in speed. If it could accelerate indefinitely, it will eventually reach the speed of light. So the speed of light, after an object has been accelerated for an infinite amount of time, the maximum speed that can be achieved when a small ball is thrown from the wall of the car. Not the speed of the ball and the speed of the car. It's the speed of the ball plus the speed of the car. So when we emit a beam of light, the speed of the car doesn't add to the light because the speed of light is already infinite. The speed of light is the infinite speed in the universe.